Alright, so this is the video for Chapter 10. This will be the last video for 1324 this semester. So 10.1 is about finding the domain given the equation of the function. So the default domain is just going to be all real numbers from negative infinity to infinity, unless you have x in the denominator, in which case the denominator cannot be equal to 0, or unless you have x inside of a square root or other even root, in which case the radicand, that is whatever is inside the radical, must be greater than or equal to 0. Alright, and then also there is a domain restriction for logarithms, but we don't really need to worry about that. Alright, so number 1, f of x equals 1/2 x plus 5. So since the domain is not in the denominator or a square root, it's just going to be all real numbers from negative infinity to infinity. Alright, number 2, we do have x in the denominator. So the denominator, which in this case is just x, cannot be equal to 0. Alright, but we want to write the domain in interval notation in terms of what can x be. Well, x can be any real number other than 0. So to write that, it would be negative infinity, comma 0, parentheses, union, parentheses, 0 to infinity. Alright, and for number 3, f of x equals negative 1 over x minus 7. So in this case, x minus 7 cannot be equal to 0. So if we add 7 to both sides, we would see that x cannot be equal to 7. So the domain would be negative infinity to 7 with a parentheses, union, parentheses, 7 to infinity. And number 4, this time we have x inside the radical. So 2x plus 4 needs to be greater than or equal to 0. So now let's solve that for x. So subtract 4 from both sides, so 2x is greater than or equal to negative 4. And then we would divide both sides by 2. So that would be x is greater than or equal to negative 2. So for interval notation, that would be bracket negative 2 comma infinity. Number 5, f of x equals the square root of x squared plus 1. So x squared plus 1 has to be greater than or equal to 0. You could subtract 1 from both sides, so x squared is greater than or equal to negative 1. Well, that statement is already true for all real numbers, because if you have a negative number squared, it's going to be positive, and if you have a positive number squared, it's going to be positive. Even if you have 0 squared, it's going to be 0, which is greater than negative 1. So this is true for all real numbers, or all real values of x. So therefore the domain in this case is still just going to be negative infinity to infinity. And on number 6, we have negative 5 over the square root of x minus 4. So that, we have two different domain restrictions. We have x in the radical, which is inside the denominator. So with x being in the radical, we would say that x minus 4 has to be greater than or equal to 0, but it's also in the denominator, so it can't actually be equal to 0. So we're just going to nix the or equal to part. So basically we're just saying that x minus 4 has to be greater than 0. So then we just add 4 to both sides, so x needs to be strictly greater than 4. So that would be parentheses 4 to infinity. Number 7, f of x equals 1 over x squared plus 5x minus 6. So we're just going to say x squared plus 5x minus 6 cannot be equal to 0. And then we could factor that. So that would be x plus 6 times x minus 1. So that tells me x cannot be equal to negative 6 and x cannot be equal to positive 1. So that means that the domain is going to be negative infinity to negative 6 union negative 6 to 1 union 1 to infinity. Okay, number 8. So in this case, again, we have both domain restrictions and one problem, but this time it's a little bit different because they're two separate things. So let's just do them as two separate things. So we would have x minus 1 cannot be equal to 0. So we would add 1 to both sides to give us x cannot be equal to 1. Then we would have x plus 4 must be greater than or equal to 0. Subtract 4 from both sides, so x must be greater than or equal to negative 4. So here's where I would like to use a number line to kind of help visualize this. So on the number line, I'm going to put the negative 4 and the positive 1, and just make sure that we put the negative 4 to the left of the positive 1. So since x cannot be equal to positive 1, I'm going to put an open circle above the 1. And it can be equal to negative 4, so I'm going to put a solid circle above negative 4. And it has to be greater than or equal to negative 4, so I would shade to the right, and I have to skip over the 1. Alright, so then to write that down in interval notation, it would be bracket negative 4 comma 1 with a parentheses union parentheses 1 to infinity. Alright, so section 10.4 is about solving exponential equations. So that means that we're solving equations where the variable is in the exponent. So we have 2 to the x equals 32, so we're basically just trying to figure out 2 to what power is equal to 32. So if you're not really sure, you can just kind of guess and check it on the calculator. Like maybe you might guess that it might be 2 to the 4th power. So then you type in 2 to the 4th power, and that's 16, which is too small. Okay, and maybe you try out 2 to the 6th power, which gives you 64, which is too big. So then maybe we try out 2 to the 5th power, which gives us 32, which is just right. So we know that 32 is the same thing as 2 to the 5th power. So basically we know that x would be equal to 5. Okay, and you know, maybe to write that out, we might want to replace the 32 with 2 to the 5th power. So you'd have 2 to the x equals 2 to the 5th, and then you cancel out the 2's. So that gives me x equals 5. Alright, so number 10, we have 4 to the power of 3x minus 5 is equal to 16. So we want to know 4 to what power would be equal to 16. And we know that 4 squared is equal to 16. So we're going to replace 16 with 4 squared and just bring everything else down. So we have 4 to the power of 3x minus 5 equals 4 squared. So then we can cancel out the 4's, and we can just bring down the exponents. So then it's just like a linear equation. 3x minus 5 is equal to 2. So add 5 to both sides. So 3x equals 7. Divide both sides by 3. So x is equal to 7/3. Alright, number 11, I have 3 to the power of 7x equals 27. So I need to know 3 to what power equals 27? Well, 3 to the third power, because 3 times 3 is 9, times 3 is 27. So 3 to the third power is equal to 27. So I would just replace that 27 with 3 to the third power, and then just bring the rest of it down. So I have 3 to the power of 7x equals 3 to the third power. And then I can just cancel out the big 3's, and then that gives me 7x equals 3. And then I just divide both sides by 7. So that gives me x is equal to 7/3. I mean, 3/7. Number 12, I have 2/3 to the power of x equals 9/4. Well, I know that 2 squared is 4, and I know that 3 squared is 9. So I just need to flip that over, and to flip over a fraction, you just use a negative exponent. So I'll bring down 2/3 to the x equals. So I can replace 9/4 with 2/3 to the power of -2. So the negative flips it over to make it 3/2, and then 3/2 squared is 9/4. So, whoops. I have 2/3 to the x equals 2/3 to the -2. So that just gives me x is equal to -2. Alright. And then number 13, e to the power of 3 minus x equals e to the power of 3 to the power of -x. So you may or may not know what e is, and that's not really very important at this point. E does represent a number, kind of like pi does. But that really doesn't matter because it's just going to get canceled out anyway. Because bring down e to the power of 3 minus x equals, and then if you have an exponent raised to another exponent, you multiply the exponents. So this would be e to the power of -3x, and then you would just cancel out the e's. So then you would have 3 minus x equals -3x. So then I would just add x to both sides. So that would be 3 equals, so -3 plus 1 is -2. So 3 equals -2x. Divide both sides by -2. So that gives me x is equal to -3/2. And then number 14, so I can't say that I know that 32 to some power is equal to 16, or 16 to some power is equal to 32, but what I want to do is try to think of a small, like, prime number that could be used as a base for both sides. So how about 2? I know that 2 to the 5th power is 32, and I know that 2 to the 4th power is 16. So I'm just going to replace 32 with 2 to the 5th power, and I'm just going to replace 16 with 2 to the 4th power. So then the 5 will just get multiplied times t plus 1, and the 4 will just get multiplied times 1 minus t. So then I can just cancel out the 2's, and then I'll go ahead and distribute the 5, so that would be 5t plus 5 equals, and then I'll distribute the 4, so that would be 4 minus 4t. So I'm just trying to solve for t, so I'm going to add 4t to both sides. And then I'm just going to go ahead and subtract 5 from both sides. So that's going to give me 9t equals negative 1. And then divide both sides by 9. So that gives me t is equal to negative 1 over 9. Alright. So number 15, I want to think of a prime number that I could use as a base for both sides. So since both of those are involving the 5, I believe 5 would be the number I'm looking for. So the cubed root of 5 can be written as 5 to the power of 1/3, and 1 over 5 can be written as 5 to the power of negative 1. And then the 1/3 would be multiplied times negative x, and the negative 1 would be multiplied times x plus 2. Okay, so I can cross out the 5's. So I have 1/3, or actually negative 1/3 x equals, I'll distribute the negative 1, so that'd be negative x minus 2. Alright, then I'm going to add x to both sides. So that's like adding 1x. So negative 1/3 plus 1 is equal to positive 2/3. So that'll be 2/3 x is equal to negative 2. So to solve that, I'm just going to multiply both sides by 3 over 2. So that would be x equals, and then the 2's cancel out, which just makes that negative 3. Okay, and then number 16, I have r to the power of 4 over 7 equals 16. So in order to solve that, we need to know the rule that says that x to the power of p over n is equal to the nth root of x to the power of p. And it doesn't matter whether you put the p on the inside or the outside of the radical. So let's see. What we could do is just say we're going to raise both sides of this equation to the power of 7 over 4. Because then you multiply the exponents. 4 over 7 times 7 over 4 is 1. So then that just gives you r equals. Then this would be the 4th root of 16 to the 7th power. And I know that 2 to the 4th power is 16, but also negative 2 to the 4th power could also be positive 16. So this is going to be r equals plus or minus 2 to the power of 7, and then 2 to the power of 7 is equal to 128. So basically r is equal to plus or minus 128. Alright, and section 10.5 is about logarithms. So logarithms are the inverse to exponentials. Just like subtraction is the inverse to addition, division is the inverse to multiplication, and square rooting is the inverse to squaring. Okay, so exponentials also have an inverse function, which is logarithms. Alright, so it's useful to be able to convert or switch between the exponential form of the equation and the logarithmic form of the equation. So if you have b to the p equals a, you can also write that as log base b of a is equal to p, or vice versa. Okay, so like number 17, I have log base square root of 3 of 9 equals x. So I've got b is the square root of 3, a is 9, and p is x. So I need to write that in the form of b to the p equals a. So that would be the square root of 3 to the power of x is equal to 9. Alright. And then number 18, I've got b is 3. I got p is 4. And I've got 81 is a. And I need to write that in the form of log base b of a equals p. So log base 3 of 81, which is a, equals 4. So we can use that to help us to solve logarithmic equations. So number 19, we have log base 2 of x equals negative 3. So we could write that as 2 to the power of negative 3 equals x. So 2 to the power of negative 3 would be the same thing as 1 over 2 to the third, which is 1 over 8. So x would be equal to 1/8. Then number 20, I have log base 10 of x equals 1. So basically 10 to the first power equals x. So x is equal to 10. And then number 21, I have log base 125 of 1/25 equals x. So 125 to the power of x equals 1 over 25. Alright, so I want to find a prime number that I can use as a base for both sides. So I could use 5. So 125 is the same thing as 5 to the third power. And 1 over 25 would be the same thing as 5 to the power of negative 2. And then that 3 could just multiply times the x. So 5 to the power of 3x equals 5 to the power of negative 2. So then you can just cancel out the big 5s. And then you would have 3x is equal to negative 2. And then just divide both sides by 3. So x is equal to negative 2/3. Alright, number 22, log base 5 of 8 minus 7x is equal to 3. So in this case, 8 minus 7x is what we would refer to as the argument of the log. Okay, so that's just a little bit of terminology for you, not that big of a deal. So we would say 5 to the third power equals 8 minus 7x. And we know 5 to the third power is equal to 125. So 125 equals 8 minus 7x. And then subtract 8 from both sides. So that would give you 117 equals negative 7x. And then divide both sides by negative 7. So x equals negative 117 over 7. And number 23, log base x of 27 equals negative 3. So that would be x to the power of negative 3 equals 27. Okay, so x to the power of negative 3 is the same thing as 1 over x to the third. So 1 over x to the third equals 27. Alright, and there's this little trick that my high school chemistry teacher taught us, which was that you can switch this with this. So that's just a little shortcut for you. And before, when I was doing the notes, I did it the long way, so you can see that on your notes. But here's the short way for you. I didn't feel like doing it the long way again, so here you go. So that's going to be 1 over 27 is equal to x to the third. So then to solve for x, I would just take the cubed root of both sides of the equation. So I know that 1 to the third power is 1, and 3 to the third power is 27. So therefore the cubed root of 1 over 27 would be 1/3. So 1/3 is equal to x. And number 24, log base x plus 2 of 81 equals 1. So x plus 2 to the power of 1 equals 81. So that is x plus 2 equals 81. And then just subtract 2 from both sides. So x is equal to 79. And then on number 25, we have log base 8 of x plus 5 equals 6. So in this case, the plus 5 is not part of the argument of the log because there's no parentheses around x plus 5. So we would just start by subtracting 5 from both sides. So log base 8 of x is equal to 1. And then we would just write 8 to the first power equals x. So in other words, x is equal to 8. And then number 26, log base 2 of 1 minus x equals 0.5. So 2 to the power of 0.5 equals 1 minus x. So 0.5 is the same thing as 1/2. And when you have something raised to a power of 1/2, that's the same thing as having the square root of whatever it is. So this would be the square root of 2 equals 1 minus x. So then you could just subtract 1 from both sides, and it would be the square root of 2 minus 1 equals negative x. Then you would just divide both sides by negative 1, so that would be negative square root of 2 plus 1 equals x. Or you could also say 1 minus the square root of 2 equals x. Alright, so that is the end of the video, and that's our last video for 1324 for this semester. So Hope you found the videos to be helpful. I appreciate any feedback that you have, and thanks for hanging in there with me this semester, my first time teaching online, and I hope it worked out for you. And just, of course, good luck on your final and finishing up the course, and of course you can let me know if you have any other questions. Bye-bye.